John Forbes Nash Jr., widely regarded as one of the greatest mathematicians of the 20th century, known both for the originality of his thinking and his audacity in approaching the problems others would hesitate to try. In June 13, 1928, John Forbes Nash was born in Bluefield, West Virginia, USA. When he was still a kid, his father would treat him unlike any other kids, as he was given science books instead of coloring books. He entered Carnegie Institute of Technology with a degree in chemical engineering, changed to chemistry, and further changed it to mathematics after getting persuaded by John Synge. Then pursued Masters in Mathematics in Princeton University, where he was also offered a faculty position by Solomon Lefschetz and also released some of his writings. In April 1950, he published his first paper in Econometrica called The Bargaining Problem, and further explained in his thesis called The Non-Cooperative Games. It took 45 years to be recognized. In 1951, he joined the faculty of Princeton University and further research into partial differential equations. The lasting contribution of Nash in economics, the Nash equilibrium, is a deceptively simple concept that has had a massive impact in the world of economics and social sciences. It served as the basis on how economists predict the outcome of strategic interactions. Towards the end of World War II, game theory was gaining popularity in academic circles. But according to Dale Jorgensen, there really wasn't much evidence that this was having much effect on the way people thought about strategic situations. Before Nash's contributions, game theory was just about zero-sum games wherein one party wins and one party loses. Nash didn't find it sufficient to explain real-life situations, so he provided a mathematical way of understanding the games that more closely depict the real world where there are no absolute or clear winners and losers. A Nash equilibrium is a situation in which a player, taking the other player's strategies as given, can improve his position by choosing an alternative strategy.
An illustration of the Nash equilibrium is the football analogy. Here we can see yellow Spider-Man give a penalty kick. He chooses to kick to the right, and in turn the goalkeeper dives to his right. On the other hand, white Spider-Man kicks left, and consequently the goalkeeper chooses to dive in the same direction. Initially, no equilibrium is seen. It may seem like an endless cycle where the goalie follows the moves of the two Spider-Men, white and yellow. In reality, we choose between two outcomes that will eventually turn into a mixed strategy, which is a probability distribution of the outcomes. According to Nash, mixed strategies equilibrium are guaranteed for every finite game, where players maximize expected utility while taking into account the players' and opponents' beliefs. The main idea of mixed strategy is to encapsulate the outcome so that there should be an equilibrium. This idea is so commonly used that every economist would have a clear understanding of how it works. The mixed strategy solution to our football analogy is that both players should choose each side with the same probability. Doing so allows both players to perform randomly and to avoid from being read by the other player. Although Nash is well known for his contribution to non-cooperative game theory, he also made a significant contribution to cooperative game theory with his development of the Nash bargaining solution. Before Nash, economists thought that the share on the gains of each of the two parties to a bargain was always indeterminate. By asking a different question, Nash was able to go on further and ask what conditions the division of gains would have to satisfy. He proposed 4 situations and mathematically proved that if these were held, there exists a unique utility maximization solution. His findings say that division of gains depends on how much a deal is worth to each participant and what each participant has. By mathematically proving that there exists at least one equilibrium point in any game, Nash helped economists, politicians, bureaucrats, and business strategists understand the world around us in a better way. The real-world applications are endless. In the field of sports, the offense decides whether to run or pass, while the defense decides whether to play against run or pass. In business, a company might decide to cheat on its taxes, but it might get audited. It can also be used as a framework for them to predict how they will respond to their competitors' prices. In the food industry, a restaurant can save money by serving leftover food, but customers may stop coming. These may seem intuitive, but the game theory actually provides a mathematical framework for analyzing these decisions. On another spectrum, the Nash equilibrium helps people understand decisions that are good for the individual can be terrible for a group. This way, we are able to use Nash equilibrium in a usual day-to-day analysis through the notion of the tragedy of the commons. It can explain why humans overfish the seas and why they emit too much carbon in the atmosphere. Everybody would be better off if only they would practice self-control. However, given what everybody else is doing, overfishing or consuming excessive fuels makes more sense at an individual level. The Nash equilibrium forms the basis for modern microeconomics, though with some refinements. Given that it promises economists the power to pick winners and losers, it is easy to see why.